Hi, everyone. Thank you for tuning in to today's micro lecture. We are starting to wrap up the future value section, the compounding section of these lectures. The last lecture we looked at an ordinary annuity, and this lecture we're going to look at calculating the future value of an annuity due. These two are slightly different based on the timing of the cash flows. Just refresh our memory. An annuity is a stream of equal payments, and they occur at the same interval over a finite period. So maybe they're monthly or quarterly, they occur over 5 years, and that cash flow is going to be the same amount. Now, an annuity due that we're looking at in today's lecture, the payments occur at the beginning of each period as opposed to the end of each period, which is what we saw with an ordinary annuity. So we have to adjust for that. And it's occurring one period earlier. This is what we essentially are getting at when we have to make a mathematical adjustment to the annuity factor. And all we're going to do is we're going to take the annuity factor from an ordinary annuity. We're going to multiply that by 1 plus R. That is our adjustment for the fact that we have an extra compounding period. So let's look at an ordinary annuity. This is what we had looked at in the last lecture. I just want to show you what the compounding periods would be just over a 5-year for a 5-year annuity. Notice that the first payment is compounded for 4 periods. And notice that the last payment is compounding for 0 periods. The last payment compounds for 0 periods because it occurs at the end of the annuity. So it's unadjusted for the time value. Now let's look at an annuity due. Same thing, 5 years, but notice that the first payment, because that payment occurs at the beginning of the period, that is compounded over 5 periods, and the last payment is compounding for 1 period because it occurs at the beginning of that period. So we have to adjust for the fact that this whole cash flow series is pushed back 1 period. Every single cash flow is 1 period earlier than it would be for an ordinary annuity, and we have to adjust for that. So let's look at the calculation. Let's look at the mathematics of calculating the future value of an ordinary annuity. This is our basic equation, and all we're doing is this left side here is just the calculation for an ordinary annuity, and we're multiplying that by 1 plus R, so that adjusts for that extra compounding period within the annuity due. So future value, of course, is represented by FV. CF is our equal cash flows, R is our interest rate, and N is the number of periods. So this is the equation that we're going to use. And of course, now we have an expanded annuity factor. Right? The mathematics are just a little bit longer. Let's look at an example. We're going to say that Sue puts $5,000 per year into an investment account. This occurs at the beginning of each period. So this is a annuity due, not an ordinary annuity. We have to make sure that we use the right equation. That account is expected to earn a 10% annual return. How much will Sue have at the end of 15 years? Well, we're going to calculate the annuity factor for an annuity due based on the equation that we saw in the last slide. We're just going to plug those numbers in there into that equation, the variables under that equation. We're going to get an annuity due factor of 34.9497. And now we just multiply that by the $5,000 cash flows, and we see that the future value of that account is $174,748.50. All right, so that is the future value of an annuity due. We're going to continue with some more time value of money lectures. This is probably the most important in terms of the basic blocking and tackling, the basic tools that we're going to use in financial management. So once we go through this, we're going to see a greater application as we start to value stocks and value real estate, use it to make internal business finance decisions. If you guys like our lectures, You can like and subscribe to our channel. It's a big help to us, and we will continue to put these out. Thanks so much, everyone. See you next time.